Excellent. So, hello everyone. My name is Vasilis Philippou, and I welcome you to our eighth webinar in the framework of the BECoop and Horizon 2020 project founded by the European Union, which aims to support the development of sustainable solid biofuels supply chains by promoting collaboration among stakeholders, including researchers, industry policymakers, and other relevant actors. This webinar is about the solid biofuel production and circular economy. I will be your facilitator for today's session, and I'm thrilled to have you all here to discuss this important topic. As we are going deeper into the fascinating world of the solid biofuel and the role in advancing the circular economy, we will explore various key concepts, insights, and perspectives. Allow me to present you the agenda of the webinar. The eighth BECoop webinar is dedicated to the process and standardize of the raw material, the equipment, the cost, and success cases of circular economy. Thus, we are thrilled to host Circe and Bioenergy Europe, as well as various example success cases that I'm sure their stories will inspire us all. First of all, the coordinator of the project, White Research, will give us an introduction about the project, and then we will pass to the more technical session, let's say, that Circe and Bioenergy Europe will present to us. Then, of course, the success cases, and finally, some time to wrap up everything and clarify potential questions you may have. So to make the most of our time together, let's keep the lines of communication open and engaging. Please feel free to ask questions, share your thoughts, and participate in the discussions. So let's try to make this webinar an enriching experience for everyone. So without further ado, let's kick off our exploration of solid biofuels and circular economy. So I'll give the floor to White Research and to Mr. Dimitrios Kapizanis in order to make a short introduction. Dimitrios Kapizanis is the project coordinator of the BECoop. He's working as a project manager at White Research, a research consultancy based in Brussels. He holds a PhD in chemical engineering with international research and management experience in the fields of environmental risk assessment, renewable energy, participatory science, and investigations of societal dynamics. He holds strong experience in the implementation of European funding programs, having effectively coordinated key activities in numerous large-scale EU projects. His experience in interacting with policy actors and translating research findings into the actionable policy recommendations. So the project portfolio that he has led includes works in scientific areas spanning from environmental health, climate, renewable energy, smart cities and mobility to bioeconomy, and of course, sustainability and circular economy. So Dimitri, thank you very much for being here today with us, and the floor is yours. Let me stop my screen. You can share the screen. You can start the presentation. Thank you very much.
Thanks, Vasilis. What an introduction. Thank you. I don't know if you can see me. I can see some of your faces. Let me try and share my screen. Yep. Let me know if you can see my screen because I think it takes some time.
Yeah, we can see.
You can?
Yeah, of course.
Yes.
Excellent. Thank you. Thank you so much. Thank you, everybody, for joining us. And thank you, Vasilis, for hosting this session. I'm sure it will be a fruitful one. As you might have known, this is part of the series of capacity building webinars we have been organizing in the framework of BECoop. And I guess you might have heard that BECoop is an EU-funded project, but I guess my job is today to perhaps say a few more words about what we really do in it. So I'll try to be brief and sharp so that we have more time for fruitful discussion and I'm not wasting your time. And that's why I'll only go through one single slide and I'll just try to give you a narrative, and you can obviously pose any questions if there's anything not clear. So what we do in BECoop, BECoop is a Horizon project, an EU-funded project, and what we try to do is to provide the necessary conditions for unlocking, for activating the underlying market potential of community bioenergy. And in our case, we obviously focus on the heating sector, as you might have known. How do we do that? We mobilize people around and we establish a better picture, a better image for community bioenergy heating projects. And through our support scheme, we aim to reduce both the time and the budget required for the successful initiation or establishment of such initiatives. Now, in practical terms, we employ market, social research. We have technical and business components. We have policy analysis, and we do focus as well on knowledge transfer. And we develop a suite of supporting tools and resources. And most importantly, we test them out in our pilot regions. And this is where we explore the development of 4 new communities, or what we call the BECoop. As you can see, I hope, in this tiny map over there, we have pilot cases in Poland, Spain, Greece, and Italy. And as you can imagine, all of these regions, they have their own specificities, right? So they represent different framework conditions. They have different renewables penetration rates, and they might have different maturity levels in terms of community project establishment. And all of this provides a great basis for us because through our explorations, our pilot roadmaps, and by providing our services, we end up with a synthesis of complementing evidence across Europe. And that actually makes our project and our approach quite replicable. Now, based on our results, our policy analysis, the lessons that we've learned, we further ignite a policy debate on the actual means by which community bioenergy can be promoted at all levels. And I should also mention that over these years, we have been studying numerous existing cases. We have been hosting several sessions and events, both physical and online ones, such as the webinars we're having right now. And we have been building quite successfully, I must admit, valuable synergies with sister projects. So I'm talking about EU-funded projects of a similar topic. And now that we basically move towards the end of our project, we take an extra step and we identify 8 additional replication cases, or follower cases, as we call them, to offer them our resources. And that practically means that our approach is promoted to 12 cases across Europe. And I should probably also say that we just submitted the BECoop replication handbook to the Commission, and this will become freely available really, really soon. But in simple words, and just to sum up, what we do in BECoop is we work towards making community bioenergy heating initiatives more appealing. And basically, in turn, we do expect that through our work, we can facilitate a higher penetration of bioenergy heating technologies across Europe. So that was more or less a quick intro, hopefully within the 5 minutes time frame that Vasilis gave me. But obviously, I'll be at your disposal should you have any questions, either now or towards the end of the webinar. And thanks again.
Dimitri, thank you very much for all this great information about the BECoop project, a project which I strongly believe that absolutely succeed to provide the necessary conditions, technical as well as business support tools for unlocking the underlying market potential of community bioenergy. So, and personally, I really thank you for the flawless coordination during the last 2.5 years of the project. So I really thank you, the great presentation. Thank you very much for being here.
It's a pleasure. Thank you so much. Thank you.
Now I would like to introduce you our next speaker, Mr. Jaime Guerrero from CIRSE, who will present us the various types of salt biofuels. Jaime Guerrero has been a researcher in CIRSE Technology Center for 2 years. He has been focused on the development of alternative biomass solutions, having participated in European projects such as AgroBioHeat, Coralis, etc., and mainly worked in gasification process. Currently, he is a PhD candidate focused on thermochemical processes for decarbonization of industries. So, Jaime, thank you very much, and the floor is yours.
Thank you very much, Vasilis. Thank you very much, Chris, and thank you very much to all our guests, because it's a pleasure to be here presenting today we're going to biofuel production, and in my case, the most common type of solid biofuel. Can you please confirm me if you can see my screen?
Yes, we can see your screen.
Yes, we
So
can.
we should start. Okay, as I've said, I'm going to present the common solid biofuels and also some other solid biofuels, giving some high-level information and some important characteristics about this type of biofuels that we are working around in the project. So biomass is, as we may know, a renewable energy source that contributes to reducing energy dependence and also reducing the emissions for coming from the combustion of fossil fuels. So the use of biomass has a long history. It has been very widespread, the use of forest biomass, which has provided throughout the years to our villages with mainly firewood, which was used for cooking and heating. Um, this has also an associated environmental benefit, not only obtaining this heating, but it keeps the forest clean of dry debris, reducing the risk of forest fires. However, in the recent decades, its use has declined compared to the use of fossil fuels due to the appearance of more convenient and economical systems that use these fossil fuels, and also due to the concentration of the population in large cities, which difficult the access to these resources. In comparison, when we were organized in villages or the population centers were smaller. So currently, the great technological advances that have taken place in this biomass sector, also the capacity to use a wide variety of products as a fuel, have made this alternative a competitive option that can contribute, as I've said, to reducing these greenhouse gas emissions. So the generation of these resources in the vicinity of many municipalities makes this biomass a solution particularly attractive, both in terms of local employment generation and also potential cost savings. In order for these local governments or associations to play an important role in the development and in the use of biomass, it is necessary to know and analyze the current technologies available, as well as the different types of fuels and their availability, which is what we're going to explore today. This way, we will be able to know which ones are best suited to the needs of the users. So we're going to speak about these most biofuels, mainly based in wood, which are the wood pellets, the chips, the briquettes, firewood or logs, and finally, we will give some information about other solid biofuels. In the first case, we can find the wood pellets, which is the most elaborated biofuel. These are small cylinders from 6 to 8 millimeters in diameter and from 10 to 40 millimeters in length, which are obtained by pressing wood sawdust. Thanks to lignin, which is a natural component of the wood that can act as a glue in the formation of this pellet, it is possible to form some small cylinders without using any other additives. The main advantages of wood pellets are the ones that I show in the slide. They have a high calorific value because they are compressed wood, they are homogeneous, and they have a constant composition, which allows to achieve very high energy yields. They have minimum ash content, which reduces the operation and maintenance needs of stoves and boilers. They have an easy supply in bags or in bulk, and they have competitive prices, especially when we are comparing them with fossil fuels. We can also find quality guarantees since the 85% of the pellet manufactured have certifications that can be M+, DIN+, or a standard that is ISO 17 2025 -2. Um, it is also a biofuel that has a lot of presence in Europe, and the equipment that uses it is numerous, very varied, and cheap. It has a main disadvantage or drawback, that is that compared to other biofuels, for example, wood chips or nutshells, the price of the pellet is a bit higher. Okay, so in 2018, the price of pellets supplies in houses with a tank truck was 240 euros per ton. Moving on, we are going to see the wood chips. Uh, these are a product resulting from the crushing of biomass of woody origin, which come mainly from wood industries such as sawmills, carpentry, forest cleaning, or prunings. They have a variable size depending on the degree of crushing to which they have been subjected. It achieves to increase its energetic value with a simple processing of drying and classification. Their main advantage is that compared to other fuels, they are the cheapest in terms of energy, especially compared to woody biofuels. In 2018, the average price of the chip for domestic use was about 108 euros per ton, so more than half than pellets. Currently, the main supply companies offer chips with a certificate called biomasud, which guarantees also this standardization, but they have also some disadvantages. For example, compared to other biofuels, they are less dense than pellets, so they require more storage space. Um, they also require more robust equipment because they have usually more or higher ash contents. In addition, the cost of distillation is usually higher. Um, then we can find biomass briquettes that refer to a type of solid fuel that is made by compacting biomass materials, such as these crop residues, agricultural waste, forestry residues, or agro-industrial residues. Um, they are compressed into a dense, high-energy, and easily ignitable fuel source. The biomass materials are typically first dried and then mechanically compressed under high pressure without the use of any binding agents or chemicals. So in essence, they are more or less the same that pellets, but with bigger dimensions. So they have these cylindrical or rectangular shapes, and they can be used also as this renewable and sustainable alternative to traditional fossil fuels. For example, they can substitute coal or other types of wood. So their main advantages is that they have good thermal calorific value and they are easy to store, handle, and transport thanks to these properties that are shared with pellets. They have also consistent combustion and ignition temperatures, and as they have been dried, they have lower moisture. Uh, this implies that they have a high burning efficiency. They also don't generate smoke, soot, or carbon deposits as they are free from ashes. The main drawbacks is that the densification process is energy demanding, but less than pelletization. They have a higher cost than other biofuels, and they require large and waterproof space requirements. And they are also affected by atmospheric conditions, for example, humidity. In the case of firewood, refers to logs or pieces of wood that are typically used for burning in fireplaces, wood stoves, or outdoor fires, which are the most typical source of biofuels that we can find. Most of us will have seen them in a lot of places. They are usually cut from trees, and this is like the most natural state without any additional processing or shaping. So they are the least developed and controlled biofuel. Although its use is in decline, the high number of chimneys in the independent homes that are not very efficient means that these traditional biofuels continue to be widely used. As the main advantages is that it's widely available because firewood is available in many regions, making it easily accessible for its use as a biofuel. It's cost effective because it can be often less expensive than other forms of biomass like pellets or briquettes, making it good, making them a good option for heating and cooking. But the drawback is that it can also present a huge price variability. And they don't have very high processing requirements because they require minimal processing compared to other types of solid biofuels. With other biofuels, it has some drawbacks. For example, they are not so homogeneous, and thus this does not allow the automatic combustion and generates greater emission of particles and ashes. They have higher emissions because of this higher quantity of ashes. They also have greater complications of storage, lower energy density compared to pellets briquettes because they have not been densified. They have a high price variability, as I've said before, and they have a high difficulty in the automation of combustion systems. And finally, we're going to see some other solid biofuels that are not as common as these forest residues. For example, we can find some agricultural residues that can be straw, corn stubble, rice husks, or sugarcane bagasse that are typically lightweight and have low energy density compared to wood. They may require additional processing, such as grinding or densification, to convert them into briquettes or pellets in some cases, and they may also have higher ash content and lower calorific value compared to wood. Um, in the case of olive stones, that are typically dense and hard and with low moisture content, and they have moderate to high energy, excuse me, moderate to high energy density and also low ash contents. They can be processed also into briquettes or pellets with high calorific values, but their most typical exploitation form is in their natural way. Only in some cases they can be dried. We can also find nutshells that are typically also hard and dense with high energy density and low ash contents. And finally, we can find coffee husks, which are typically also lightweight and available as byproducts of coffee production, which as coffee is so extended its production, this makes a very big advantage for the availability of this biomass. So this is all from my side. Thank you very much, and I hope that has been interesting. And of course, I remain at your disposal if you should have any doubt or question on whatever. Thank you.
Thank you, Jaime. Thank you for a great presentation. Thank you for sharing with us the science of your insights about the salt biofuel. That was very useful for everyone. So really thank you for being here today. Our next speaker brings a wealth of knowledge on exploitation of residual biomass, and we are very excited to hear from Mr. Manolis Karambinis about the cost of salt biofuel production and, of course, the certification schemes for produced salt biofuels. Mr. Manolis Karabinis is the Director of Business Development and Membership in Bioenergy Europe since October 2022, responsible for the growth of the association's network and activities. His duties in Bioenergy Europe also include the management of the European Pellet Council, the network of national pellet and biomass association, and the coordination of the working group on pellets and agrobiomass. Manolis is a chemical engineer and holds a master in energy generation and management from the National Technical University of Athens. He has been involved in the bioenergy sector since 2006, focusing in large-scale and industrial bioenergy applications and mobilization of underutilized biomass feedstock, such as agrobiomass. Manolis also worked for 16 years as a research associate in CERF, involved in numerous EU-funded projects related to technical development and market uptake of the bioenergy sector. Since 2017, he has served as a board of a member of Elavion, the Greek Bio Association, and from 2019 to 2022, in the board of directors of the Bioenergy Europe. So Manoli, we really appreciate that you are here with us today, and the floor is yours.
Many thanks, Vasilis, and I could not do otherwise since the only thing that you missed in your very detailed introduction is that I've been also involved, and still I'm involved in the BECoop project as well. I was there since its inception, and I still follow its activities. But in the BECoop, we go, and in some other projects that I've been involved in, we go mostly into the unexplored feedstocks, the spent coffee grounds, for example, with which ESEC is working on the moment is such an example. But today I will focus more on the more structured markets of biomass in Europe. And the most structured market is actually the pellet market, the wood pellet market. So I will be mostly speaking about this. Give me 1 second to share my presentation. And please confirm if it's going on full screen.
Yeah, it's perfect. We can see your screen is full screen.
Yes. Perfect. Okay, good. So I have a few things to cover. I will start with a very short introduction about Bioenergy Europe and the European Pellet Council before moving on to the pellet markets, as well as the EN Plus certification scheme. So about Bioenergy Europe, we are a trade association. We are based in Brussels, and we represent the interests of the bioenergy sector towards the European institutions, the European Parliament, the European Commission, the Council, and so forth. We have around 190 members. Many of them are national associations which represent the bioenergy sector or the pellet sector in the respective countries, as well as around 150 companies from all the value chain steps of bioenergy, from fuel producers to traders, technology providers, equipment manufacturers, end users, and consultancies and academic research partners. We are hosting the European Pellet Council. We are involved in 2 certification schemes. SURE is about biomass sustainability and the requirements imposed under the Renewable Energy Directive, and EN Plus is a scheme focusing on wood pellets, and I will talk more about that in a while. We do provide several services to our members. Of course, the core business is the EU policy monitoring and influence, I could say, and this is why we are in Brussels. But also we are active in market intelligence and also provide several opportunities to our members for visibility, networking, and so forth. A lot of our work is being structured around working groups. Working groups have a theme, some of the main policy or market files that we are following. So, for example, we have a working group on sustainability, and it's the one that is following and was following until recently the discussions about the Renewable Energy Directive, and then it had to do with bioenergy in that. But we also have some working groups like the pellets one, which are much more market oriented, and we use it as a platform to share among our members market updates. Beyond those meetings, we also publish a series of statistical reports. Again, this is a publication available only for our members. And one of the, let's say, we break this down into several parts, each one focusing on specific aspects of the bioenergy sector. We have a dedicated report on the pellet, and it's one of the most popular because it compiles information from the EPC members as well as from several other external contributors, and it's information you cannot really find on other open sources such as Eurostat. It's really data that our members collect and we aggregate. And I've already mentioned EPC, the European Pellet Council, several times. So EPC is a network, an informal network within Bioenergy Europe. It brings together the associations in the EU member states that focus on the pellet sector. So what do? We manage the EN Plus scheme, and of course anything else that has to do with communication, advocacy, market intelligence, and networking related to the pellet sector is something that is being done under the auspices of the EPC. Very recently, for example, we have launched a new series of events called the European Pellet Forum. We had the first edition in January in Graz. And next year it will be in Nantes in France, and the idea is that this will be the main forum for the residential pellet markets in Europe, the premium pellet markets, as we call them. And moving on to that, I go into some details about the European pellet markets, because this is, Jaime already mentioned, this is the most advanced form of solid biofuel. You can say it's a commodity, essentially. You can find them in, let's say, very standardized forms and other specific product specification. And this really facilitates trade, along, of course, with the core characteristics of the product, the high energy density. So if you look at the global perspective, and if you focus on the red and orange bars, these are the consumption data. So it's quite clear that the EU is the world's largest pellet consumer. Other Europe includes here in this chart mostly the UK, and there this is mostly used for power generation. We have a growing pellet market in Asia, in Japan and Korea, basically, again for power generation. And we have one big exporter in the world, which is North America, the US and Canada, exporting mostly to the consumption markets, the EU and Asia. But from the green bars, it's already quite clear that the EU is not only the world's largest pellet producer, it's also the world's biggest pellet producer. And I can go into some further details about how the market in Europe is structured. First, going to the production side, the big player is undoubtedly Germany, the biggest producer in Europe, but we have other countries like France, Poland, Sweden, Latvia, and Austria, which are definitely above the 1.5 million tons of pellet production per year. Some of them go around 2. million tons of pellets production per year. But again, if you look at the map in more detail, you will see that pellet production basically takes place in most of the European countries, and pellet production in Europe is very much closely related with the wood processing industry, because primarily the European pellet mills are using sawmilling and other wood processing residues for the pellets production. So long story short, you can find a pellet producer most likely very close to where you're living in Europe. If you go now to the pellet consumption, you might notice, and this might not, for those of you that are not so familiar with the pellet markets, that UK is the biggest consumer of pellets. However, there is a very specific reason why this is so, and this is industrial power generation. UK hosts 2 power plants. One of them is very well known, Drax, and it alone consumes maybe 8 or so 7 to 8 million tons of pellets per year for power generation. So it's a bit of an outlier, I would say. In other countries, you also have large-scale industrial pellet consumption. But countries like, for example, Germany or France and Italy are definitely more focused on the heating market for pellets, residential or otherwise. And if you look at the latest data that we provide for 2022, quick note here, these are provisional data published in our preliminary pellet report. We expect the final data to be available in autumn for last year. You will see that in the United Kingdom, for specific reasons, there was a reduction of consumption last year, while the residential markets were continuing to grow in Germany and France. And a bit more focus on the heating market. Again, Germany, the biggest heat consumption market in Europe, and by far, let's say, the largest share of the consumption there is residential. The same applies to Italy. It may not be well known to everybody, but Italy is a big consumer of pellets. It's mostly done on the residential scale, and it's a net importing country. They import pellets from pretty much everywhere for the residential sector. France, another growing market for the heat sector, and Denmark and Sweden are a bit more specific cases because there some of the pellet consumption is also related to larger combined heat and power plants and not, let's say, small-scale pellet stoves and boilers. But I mentioned several times the residential sector, and I imagine that several people who are in this webinar with us are representing energy communities or wanna be, in the good sense of the word, energy communities. Aspiring energy communities might be a better term. And most likely, these people will likely cater, if they establish a pellet activity, like ASEC did in the past, to the residential markets or the small-scale commercial markets. And therefore, in those market segments, the consumption is very much related with the level of the pellet appliances. You need a pellet appliance, either a stove or a boiler, to use pellets. When you're talking about the stoves are obviously used for, I would say, room heating. They are more, let's say, small scale and in the narrower spaces. The biggest markets by far in Europe are Italy and France. If you look at the Italian stock of appliances, we have around almost 2 million units of pellet stoves. You might notice a decreasing trend in the last years. This has to do mostly with replacement of older appliances with new ones. Sales of appliances still go high. And France is a market which has not yet reached, I would say, maturity, but still increasing. And you see that the installed stock of pellet stoves is still going up year by year. If you look on some other markets for stoves, then there is again a growing trend, especially in Spain or Germany. But the reason I have not the two figures together is because there is not the same level of installed stock. So you would not be really able to understand anything by putting together France, Italy, and even Spain, for example. In Spain, in 2022, according to the data that we have exceeded 500,000 units of pellet stoves, so still a growing market. Now, if you look at the boiler segment, boiler, of course, are bigger devices, higher installed capacity, so more pellet consumption. Again, the leader in Europe is Germany, followed by Austria, and then you have Italy, France. Poland is a very emerging market segment, and then we have Spain, based on the data that we have. And in principle, in most of the countries, we still have, as you can see here, maybe even from the graph, a big increase of pellet appliance from year over year. You can see that very clearly, for example, in Germany or in Poland, if you compare 2020 and 2021. And usually this is also done through government incentives, so some programs that have allowed households or other end users to substitute their fossil fuel boilers with a pellet appliance. So obviously this is a big stimulus for the development of the residential pellet market in Europe. But in the last 2 years, let's say, you all know that we've had a an energy crisis, actually, which has reflected also on the pellet markets. For many years, this figure is maybe not the best to demonstrate this for those who are not following the market, because it starts in January 2021. But even if it went earlier than that, you would most likely have seen a flat line, almost flat line, because really the fluctuations in the pellet prices in almost every country were insignificant compared to other energy products. And that was a very key selling point for pellets. The price was very, very stable. It took the war in Ukraine and a conflict that has escalated into a wider financial and energy crisis to turn the tables. And since, let's say, last year, from spring and with a peak in the summer and early autumn months, we have seen unprecedented levels of pellet prices in Europe, in almost all the member states. Since the peak, prices have started to go down. They still remain at higher levels than historical values, and we are often asked the question why this is so. There is not one simple answer to this. There are multiple reasons. One reason, of course, is that in the past, some of Russia was and still is, I guess, a big pellet producer, and it was mostly an exporting country. And with the EU sanctions, the imports of pellets Russian pellets in Europe was no longer feasible. So there were some supply deficits last year. Of course, with inflation, you increase the production costs all across your value chain. You have sometimes shortages of raw materials, sawdust, because there has been a slowdown in the wood processing industries, again, because of the crisis. And a very big reason is that we've had also a panic in the market, especially in the summertime. People were anxious about the winter. They were not sure what the situation would be and whether we'd be able to find pellets. And we had a lot of panic buys in the summer months, especially. So fortunately, most likely, the winter was very mild this year, I think, across most of the European regions. So this means that we didn't see the worst of it, and the long-term expectations for the market, for the pellet market, is that we might have some pricing issues in the next year, but in the long run, meaning in 2 years from now, 3 years from now, it will be much better because there will be new pellet production capacity coming online, which would somehow balance out any structural deficits that we may have at the moment. One final note before I move further. You all know, if you're based in Europe, that the government has spent tremendous amounts of money to support the electricity markets and the gas markets. But when it comes to the pellet markets, because I guess we are still quite small, the governmental responses have been suboptimal. And basically, there was no European strategy and no even national strategy in many cases. What we have seen in some countries, there has been a wave of VAT reductions in the pellets, bringing them more closer to the low VAT rates that apply to other energy products in those respective countries. We have seen that in Spain, in Italy, and Portugal. Portugal indefinite duration. For Spain and Italy, I think it's until the end of the year, but it may be extended. Nothing in Greece, I'm afraid to say, despite the lobbying efforts from the National Association. So there is still not a very unified response, and things can definitely be improved. So that is more or less the situation in the pellet markets in Europe, for those that you wanted to learn more about this, and a few things about the EN+ certification scheme. I think was mentioned quickly by Jaime in his presentation, so I have to give, let's say, a very quick introduction about this. So what does EN+ try to do? To harmonize essentially the quality levels of the wood pellets. It's a fuel quality certification scheme. And the aim of a fuel quality certification scheme is to build up confidence in pellets as a fuel. Basically, at the end of the day, consumers should know that when they buy an EN+ pellets, they buy a product of specific quality parameters that they can use in their appliances without issues. EN+ is a third-party certification scheme, and maybe a short clarification here. A standard and a certification scheme are not the same thing. A standard is a document that provides some guidelines. A certification scheme, especially a third-party certification scheme, is a system that uses the standards but applies some procedures to ensure that it is followed by people in the value chain. So how does it work in practice? We have the management of the system, the central office in EN+, the European Pellet Council, that set up the requirements for the system. Then we have some independent, bodies, the conformity assessment bodies are, as we call them, that visit the people who are involved in the wood pellet value chain and check and verify that they comply with the requirements. And then you have the certified companies that, if they pass the tests and the audits of the conformity assessment bodies, then they are allowed to use the EN+ trademark. EN+ is a system that covers the entire supply chain, so you can have producers of wood pellets who are certified with EN+. You can have traders of wood pellets certified, but also service providers. In some market segments, this may be a more familiar picture. In others, like Greece, might not be so familiar. But a service provider could be, for example, someone who is delivering bulk pellets, EN+ certified bulk pellets, to an end consumer via truck. In Greece and other markets, it's mostly bulk pellets, so this may not be so familiar. So some key characteristics of the system: it's based on the ISO standards, but some requirements are even stricter. There is an annual control of the certified companies by independent bodies, including sampling done by inspectors. There is a quality management system that the companies should use throughout the year to ensure compliance. There are procedures to handle any types of complaints about quality or fraud cases, people that are illegally and improperly using the EN+ trademark. People involved in any part of the certification scheme, like producers, the quality managers, the conformity bodies, they need to be trained. And there are requirements about the proper use of the trademark. I don't know if I need to go to a lot of details about the history, but the scheme has already several years of operation. It was established in Germany in 2010. Now it's managed by the European Pellet Council, and there is a local management in some countries by what we call national licensors. In some other countries, we have national promoting associations who are only active in promoting the scheme, while the management is done by the central office in Brussels. And the certification board, the conformity assessment bodies, are people active in certification, inspection, or testing of pellet samples, for example. The market coverage, I don't hope you can see the graph as it evolves. The system started in Germany, as I mentioned, but now in 2022, we have reached 50 countries, more than 1,200 companies. We are present in 6 companies, and we are recognized as the world leading pellet quality certification scheme. Maybe a small note here just to clarify, because this is not apparent in the graph, that since April last year, the EN Plus certified producers that were active in Russia and Belarus are suspended, and soon any certificates will be terminated anyway. So this part of the world that you see is not longer part of the system. A few figures in 2023. Very recently, we reported that we will reach 14 million tons, 14 million tons of certified pellets by the EN Plus scheme. Again, when you look at the top producing countries for certified EN Plus pellets, you find Germany at the top, but also Austria, Poland, Belgium, France, and Spain. And if you look at the countries with a higher market share of EN Plus certified pellets versus the total pellet consumption for the residential markets, you find again Germany, but also others among the top ranking ones. The market impact, one very important thing for us is that pellet appliance manufacturers, producers of stoves and boilers also many times ask that their products be used with EN Plus A1 or A2 quality pellets, because there you have the best efficiency, the lower maintenance cost, and the more consistent operation for end users. And final slide, I promise for today, is that we also get as a scheme very positive feedback from the companies that are certified by the scheme. So most of them report that EN Plus certification is essential to their business. They need it to be active. A lot of them also mention that the scheme allows them to access the European pellet market, that it helps with their internal quality management, and also that the scheme is transparent compared to other, let's say, competitors. And maybe final note, I guess, as I said before, several of you are or might be in the future energy communities that want to expand in the pellet market. And a good question would be, why would we go for an EN Plus scheme? At the end of the day, it's what I mentioned. Consumers will most likely, in many markets in Europe, will ask for such a scheme. But also, if you're planning to do business with the institutional end users, so municipalities, for example, hospitals, and so forth, it might be the case that any kind of procurement contracts will require that there is a kind of fuel quality certification scheme in place, because these end users will invest in some kind of boiler system, and the boiler system will need some fuel that is certified in its quality to operate properly and keep all the guarantees that the manufacturer is providing. So I think that's all from my side. Open to any questions that you may have, either online or on the chat, and thank you very much for your attention.
So Manoli, thank you very much for the presentation. I'm sure the participants found the presentation very informative and extremely useful. So thank you, really thank you for being here with us. Yeah.
Maybe a little longer than was expected, but
It's okay. It was very informative. So I'm sure that everybody really enjoyed whatever you said. Now it's time to shift our focus to success cases of salt biofuels producers, and how those examples of circular economy are closing the circle by producing the salt biofuels. So without further ado, I would like to give the floor to Mr. Nikos Damatis from Elaviom. Mr. Nikos Damatis is a production and management engineer with an extensive experience in installation and operation of processing units in the sector of biomass, residues, and bioproducts valorization for bioenergy generation, as well as for production of salt biofuel pellets and briquettes, pelletized animal feed, and granulated organic fertilizers. He has been elected in the position of Secretary General of the Board of Elaviom, a non-profit organization, one of the primary associations of renewable energy sources established in Greece, and a member of its European counterpart, Bioenergy Europe. Elaviom, of course, promotes the sustainable utilization of biomass at regional, national level for the benefit of the local communities, environment, and of course the economy. So Mr. Nico, thank you very much for being here. The floor is yours. You have 15 minutes.
Thank you, Vasily. Thank you, all the organizers of BECoop for this webinar initiatives. I'm glad to be here with you, and I would like to share my screen in order to start the presentation. Just to see if it's can be seen in full screen.
Of course, it's full screen. We can see it.
Yeah, okay. So I'm going to talk about valorization of biomass waste streams in the forestry and agricultural sectors and give a couple of successful cases that can be applicable in a bioenergy community context as well. A few words about Helabiom. The Hellenic Biomass Association, as Vasily said in the introduction, is active more than 30 years in the renewable energy business. It has a pool of members and stakeholders of more than 100 persons and companies. 75% are individual scientists, engineers, and researchers. 25% are corporate companies, academic and research institutions, which share common interest for sustainable biomass valorization. Helabiom is a full member of the Bioenergy Europe and of European Pellet Council and a reciprocal member of the German Biogas and Bioenergy Society. Our main objectives has to do with the promotion of scientific research and sustainable biomass valorization, provision of consultation and educational services to stakeholders, cooperation with stakeholders on the appropriate implementation of European standards and directives on biomass-related issues, implementation of service and contribution to the annual statistical reports of Bioenergy Europe. Our objectives are being met through lobbying, bioenergy policy advocacy, consultation with government bodies and committees, communication activities with conferences, workshops, webinars, and the Biomass Day annual conference. Positioning biomass in a modern bioenergy context, biomass has a broad activities and a broad application spectrum. In the bottom of the value chain pyramid is the bio-based electricity, heat, and biofuels. And as we move to other levels to the pyramid, we can see applications in the broader bioeconomy sector, in the packaging sector, food and feed industries, and the medical sector. Depending on the biomass feedstocks, the quantity, the seasonality of the feedstocks, the processes being used, and the products and services being produced, there is a mix of applications that we could have in any biomass project. In order to assess what is the available domestic biomass potential, basically this is an issue, this a question of fractions. Usually when a study is being made, we are talking about the theoretical potential in the beginning, which is the maximum amount of biomass that can be produced at a given area. Out of that, there comes the technically disposable biomass potential. It is a fraction of the theoretical one, and it represents the biomass that can be collected, taking into account local limitations and using contemporary equipment. The technically exploitable biomass potential is again a fraction of the disposable one, because it relates to the biomass that can be available, that can be collected by using existing technical equipment without incurring extra capex costs. And finally, the sustainable, at the heart of the model, the sustainable potential is the one that remains after taking a sustainability perspective and consider economic, environmental, social, and political constraints. Usually, this depends, of course, from country to country and internally within a country, and it depends also on different activities and different seasonality that these activities take place. In order to, we can have a look on the assessment of the different sectors. So we're talking about the agricultural sector. The theoretical potential, it's about 8.7 million tons of dry matter per year, while the technically disposable potential, it's about 5.5, which corresponds to about 28 terawatt hours per year. The main agricultural biomass residues are cotton residues with 1.3 million tons per year, straw 1.1, and olive tree pruning at about 1 million tons per year. And then we have also residues from other agricultural cultivations. The technically exploitable now biomass potential, it is estimated to be around 1.5 million tons for crop residues, and for orchard tree pruning, it depends. There is a range there from 1.5 to 2.5, so from 3 to 4 million altogether, which corresponds to 1 billion liters of oil equivalent. So this is really a good quantity that can be mobilized. But of course, there are many challenges which result from the insufficient agricultural waste management, which takes place mostly nowadays, still through open burning and through landfilling. The challenges are, of course, the hazardous practices for the outbreak of wildfires and the degradation of air quality, which of course has devastating consequences for human health and life. There is emission of greenhouse gases into the atmosphere, both methane emission due to the decay of organic matter, but also emission of carbon dioxide due to open air burning. There is ecosystem destruction of useful flora and microorganisms which reside into the soil. In case of in situ incorporation, there is the danger that we incorporate into the soil pathogens and diseases to the next crop cycle. And ultimately, it's an expensive task as it involves employment, personnel, and mobilization of technical equipment to concentrate the residual biomass to a specific spot. And most lately, it also relates to loss of export opportunities, because there are quite a few companies with export activities from Greece to other countries, and that are not able to always achieve export due to because they are not meeting specific sustainability criteria, including the waste management of residual biomass in the fields. Talking about the forestry biomass potential, the estimation is that there is a dry matter of about 400,000 tons per year, with which an energy content of 2.1 terawatt hours per year. It is concentrated mostly in northern part of Europe, Central Macedonia and Thrace. And again, here there are still challenges resulting from the insufficient waste management in the forests and the urban groves. Again, risk of outbreak of large-scale wildfires, which unfortunately we have seen in the recent years in Greece due to lack of sustainable forestry management. Release of methane, which is a potent greenhouse gas due to the decay of woody organic matter into the forest. Another challenge is the lack of incentives for the local workforce involved in forestry, and this results in aging of logging populations and rural abandonment. And also there's a loss of opportunities if there's no sustainable forestry management to transform the forest to a modern biorefinery that would meet the needs of modern circular bioeconomy at all levels, in sawwood for construction, in pulp for pulp industry, bioplastic fibers, bioadhesives, bioenergy, and biofuels. In order to mobilize now, in order to have these fractions available and come to the end user, the typical flows of supply chains of the woody biomass and energy crops in the agricultural sector can come either through energy crops, this is in the forestry sector, can come either through short rotation copies, energy crops, which can be moved directly to the end user or in the field pre-processed by chippers. Or if we're talking about roundwood logs, can be transported to a terminal chipper, stored temporarily, and then moved to the end user. And also we have the byproducts of the woodworking industry, of the sawmills, which produce useful products from the construction industry, and byproducts which can go for bioenergy purposes and for pellet production. In the agricultural sector, there is a combination of different machinery that can be used according to the initial plantation and the type of agricultural residue. So these residues can be either temporarily stored or directly transported to the end user or stored in order to cope with seasonality problems. And this can be done if we're talking, for example, for straw into bales, or it can also be with modern machinery in the field, shredded and pelletized, and stored closer to the end user. We are going now to look at two examples, one in the forestry sector and one in the agricultural sector, about valorization of biomass waste streams. And one example is about the environmental problem of tree branches that are coming in close proximity to the electrical power lines, both in rural areas and in urban areas. As we know, when a tree branch touches a power line, the tree is electrified, current passes through the tree's tissues and into the ground. The consequences can be devastating for human life and property, and this problem has to, of course, to be tackled. In this particular example, the recycler company undertakes the trimming of the branches to avoid damage, so it acts proactively. It has a compensation fee. It is paid for to cover these operating costs, and these are done on an annual recurring basis. The recycling company concentrates the woody biomass in its facilities. This material is being blended with other woody biomass feedstocks that are coming from the woodworking industry, and they are eventually transformed. They are produced into wood briquettes. And this valorization model could be followed by utility companies, private contracting companies, energy communities, or energy service companies, ESCOs. A typical layout of a briquetting line, which has this process in place, is that it can receive the shredded material either through a moving floor or by truck, and then this is forwarded to a combined milling and drying unit, which reduces the size and achieves the required humidity for subsequent briquetting. And then it passes through a briquetting press, which can take different shapes and different section profiles. And after the cooling line, it is being cut to the desirable sizes, and it's being packaged and stored. Some photos of this installation. This is a partial view of the moving floor, where the trim material is being loaded. Then it is moved to the combined milling and drying process, where the principle is that on one inlet is the hot air coming from the heat generator, and on the other inlet is the feedstock. The principle here for the operation to take place in the same chamber is simple. It relates to the fact that once a particle is smaller in size, it can be more easily dried, and if it's drier, then it can be more easily trimmed. So this process is a continuous process, and once a dynamic selector on the top is seeing that the humidity is ideal and also the granularity is the one desired for downstream activities, then the material is passing through a cyclone and it is being received at the bottom of this station. Afterwards, it is being moved to a temporary silo on the top of the briquetting line. And also there's a second silo sometimes when we wish to give a better binding quality to the material, usually consisting of lignin. And the material at a humidity of 10%, it passes through the briquetting press. And of course, after the briquetting press, after a long briquetting line, which, as I said, it comes in a compact form of briquette, but it can also have a hollow in the middle, depending on what is the desired air circulation during the combustion. So, a second example comes from the agricultural sector, a successful case. Again, here we have a very common situation where the residues in the vineyards are being left in the fields and are being burnt in order to be destroyed. And this is a practice, although it is banned from spring to summer, we still see it in the Greek countryside and in many other countries, especially in the Mediterranean zone. There are hazardous fumes released to the atmosphere, and this is also a problem for health. In the example that we are looking at, the vineyard operator company undertakes the baling and collection in the vineyard, and it transports the bales to a nearby sorting and post-processing for facility. The purpose is to produce a secondary product which would complement and add value to the wine and food tasting and recreational barbecue activities and markets. The valorization model could be replicated by vineyard operators who have access to vineyard pruning collection machinery at close proximity to their plantations. It can also be undertaken by agricultural cooperatives as well. The preparation of feedstock for valorization through the briquetting technology comes through appropriate machinery which goes into the field. It collects into bales the vineyard residues. And then there is a bale chipper, again mobile into the field or stationary in a nearby location, which is used to shred the pruning to particle size maximum of 15 by 5 by 2 millimeters, which is the ideal size to be then forwarded to the briquetting presses. And the moisture content, which should be around 10%, but it is usually very dry, this material, this feedstock, and sometimes it is needed through the briquetting process to add the water instead. Now for the briquetting operation, the milled pre-processed material is being stored into a standard dosing silo, shown in the picture here. The silo feeds one of the briquetting presses for the production of briquettes. Usually the diameter is 90 millimeters, and there is a hole, or can be without hole, of 20 millimeters. And the standard capacity for a cost-effective investment in this case is from 1,000 to 1,500 kilos per hour. Consumer briquettes are produced in a continuous string and conveyed in an automatic saw or a briquette breaker. And then there is a long cooling line, about 30 meters. It is very important to allow the briquette string to cool down and harden enough in order to be handled later on for shortening and packaging. And there is also a material, the material that can be transformed into a pack instead of a briquette. These are smaller briquettes that have a length of 15 to 15 millimeters. So there could be two different kind of products. On the left-hand side, we could have the briquette packs for the barbecue and recreational markets, and this also is a replacement of charcoal. And on the right-hand side, we would have briquette logs for wood and pizza ovens, and also closed-type energy fireplaces for better efficiency. And in this case, in this successful case, the vineyard operator and wine producer can expand its business opportunities while informing the consumer markets about the biocircularity of the whole production process. So, by concluding the presentation, we must say that the sustainable valorization of biomass waste streams obviously goes hand in hand with viable socioeconomic models. Considering the biomass fractions, logistic costs, and end product service value, this is often a complex and tedious exercise. And while we are determining the value of the end-use application, it is essential to decide whether to embark or not in the biomass valorization project. But it is also essential to take into account the cost of not handling the waste. Usually we neglect to see that there is no zero-cost solution. So unless the residual biomass has a value like a gate fee, then the investment could not pay off, and it is difficult to pay off. This example is ideal for energy communities, farmer cooperatives, ESCOs, public-private sector schemes, and can mobilize biomass waste streams. And only these schemes, in our opinion, can be efficient enough because their members have widespread biomass, whereas an investor on its own doesn't usually have the biomass, and unless it has a vertical production also, as it is, for example, in the vineyard industry. So I would be happy to answer any questions. Thank you very much for your attention.
Thank you, Mr. Damati, for the inspiring presentation you shared with us. I'm sure our audience found it very informative and very engaging. We have, of course, exceeded the time, but it's perfect. We really enjoy whatever you present to us. So as we continue our conversation on biofuels and the circular economy, let's welcome Mr. Nasos Makios, who will present us how Klimis company combined the biofuels and circular economy. Mr. Nasos Makios has a bachelor degree in physics science from Aristotle University of Thessaloniki and a master degree in bioeconomy, circular economy, and sustainable development at the University of Piraeus. The last 12 years, he worked as environmental management in Klimis, a family-owned company in Kalamata. Also, he is a member of the strategic planning group and coordinator of the circular economy and waste management axis of the municipality of Kalamata in the mission of the city to the 100 climate neutral and smart European cities by 2030. Mr. Naso, thank you for being here with us. We're very happy to have you here, and the floor is yours.
Good evening to everyone. Just a moment, because I have a problem.
Yeah, of course, we can see your screen, but I presume
It's at the end.
The last, yeah.
Yeah, just a moment.
Yeah. So maybe the webinar, it might took a little longer that we have calculated. It was supposed to end at in 15 minutes. So we have, of course, half an hour for 2 presentations, and then we close. Mr. Nakio, the floor is yours. Naso. Yeah.
Good evening to everyone. First of all, I would like to thank the organizers, and especially you, Mr. Philippou Vasilios, for the invitation for this webinar. I will present to you how we create barbecue briquettes out of exhausted olive cake, called in Greece perinoxilo, in a circular, efficient, innovative, and sustainable way. Klimis Company is a small family-owned business established in Kalamata in 1968. Just to have in mind that 99.9% of Greek enterprises are SMEs. We produce lime products which are separated in two categories: quick lime, which is used in a form of powder to agriculture sector as a fertilizer, and putty lime, which is used as a building material in construction sector. From 1992, more than 30 years now, we produce and distributing in the market an innovative product for barbecue, the Klimis olive barbecue briquettes, which is replacing in success wood circle. Before we go into further details about the way we produce these products, I want to present to you some scientific data about wood circle from a foresight brief of United Nations Environment Programme on 2022, with title "Charcoal as a Global Commodity. Is it Sustainable?" Charcoal is typically made from trees, is perceived to be a renewable resource, and is used in both low and middle-income countries, as well as high-income countries. There is a difference, however, between renewable charcoal that is primarily produced through the farming of trees and non-renewable charcoal produced through deforestation. Even so-called renewable charcoal has a detrimental effect on the environment through the use of monoculture, which compromises biodiversity. So, as you can see on this slide, global wood charcoal production has surged from 36 million tons in 1997 to 54 million tons in 2019. More than half, almost 59%, was produced in Africa, followed by the Americans, 22.3%, and Asia, almost 18%, with small quantities produced in Europe, 1.2%, and Oceania, 0.1%. As you can see on this slide, the major tropical wood charcoal producer countries are Brazil, Nigeria, Ethiopia, India, and Democratic Republic of Congo, countries which are losing significant biodiversity and forest cover every year. According to WWF in Germany, at the report with title 2020 Analysis of the EU Charcoal Market, almost 1 million tons of charcoal are consumed in the European Union each year. Only a quarter of it is produced in Europe. The remaining 3/4, just under 750,000 tons, are imported, most of it from countries such as Ukraine, Nigeria, Russia, Indonesia, or Paraguay, where corruption, illegal logging, and forest destruction are widespread. In Europe, Germany by far is the largest importer of charcoal among the EU countries. According to Food and Agriculture Organization of the United Nations, at the report with title The Charcoal Transition, an estimated 1 to 2.44 gigatons carbon dioxide equivalent of greenhouse gases are emitted annually in the production and use of fuel wood and charcoal, which is 2% to 7% of global anthropogenic emissions. These emissions are due largely to unsustainable forest management and inefficient charcoal manufacture and wood fuel combustion. Charcoal production, in particular, has risen in recent decades as demand has grown among urban population and enterprises. Where demand is high, mainly in sub-Saharan Africa, but also in Southeast Asia and South America, unsustainable wood harvesting and charcoal production contribute to forest degradation and deforestation and to greenhouse gas emissions along the charcoal value chains, especially when charcoal is produced using inefficient technologies. In addition, deforestation and forest degradation may both cause biodiversity loss because of the reduction of habitats and their fragmentation, as well as the loss of crucial ecosystem functions. The selective extraction of wood species for charcoal production may also lead to changes in species composition in forest and woodlands with undesirable ecological consequences. But there is a conclusion coming from the foresight brief of United Nations on 2022, which says innovation and policies aim at producing charcoal from organic waste materials are urgently required to prevent further forest degradation and loss of biodiversity, and to increase the sustainability of this material. And this is what we do in practice for more than 30 years here in Kalamata. Let's see how. The city of Kalamata is located in the south part of Greece at the region called Peloponnesos. It's a known worldwide area for the production of olives and olive oil. Greece is the world's third producer of olive oil. On 2021-22, we have produced approximately 200,027 tons of olive oil, and in Peloponnesos regions, in which Kalamata is located, we produced almost 33% of that quantity. To produce our products, we use limestone. Limestone is a type of sedimentary rock with a high percentage of calcium carbonate. Limestone has many usages in real-life application by its own. Many structures have been carved out of limestone, and many buildings have been built with limestone. Some examples are the Empire State Building in New York, in the United States of America, and Houses of Parliament in London. If we go further back in time, the external structure of the Great Pyramid of Giza in Egypt is made of limestone, as are the walls of Machu Picchu in Peru. This shows that the usage of the limestone as a building material is not a recent innovation. Throughout our day, we use products that are produced using lime. Lime is a very versatile material that's essential to a wide range of processes, from food production to paper. We will need to do a new presentation for that, but as you can see on this pie chart, the usage of lime in agriculture and as a construction material is 2% and 11% respectively. Now, what we really do in simple words, we bake limestone in a kiln. The process is called calcination. By doing that, we achieve a thermal decomposition to the limestone in a temperature at about 1000 degrees of Celsius, and we create quicklime. The chemical name for quicklime is calcium oxide. In order to bake the limestones, we need a fuel. For us, that fuel is a byproduct from olive oil production, which is called exhausted olive cake, commonly called in Greece pyrinoxylo. It is a sustainable biomass fuel. At this slide, you can see the internal structure of the olive fruit. The fuel we are using, and is visible on the right picture, consists of the endocarp, the stone, which is fragmented, mesocarp, the flesh or pulp, epicarp, the skin. The exhausted olive cake is a remnant from pomace factories produced during the process of collecting olive oil. When we collect the olives and we get out the olive oil in the olive mills, the remnant of that process goes to pomace factories to get out pomace oil, and the remnant of this process, which consists from the skin, the flesh, and the woody part of the olive pips, is our fuel to our kiln. But in our kiln, there is an incomplete combustion of the exhausted olive cake. So a black powder is creating, as you can see in this picture at the right bottom of this slide, during the heating process of the limestones. And grandfather Klimis, the founder of our company, thought back on 1977 to use that black powder again, and by compressing that powder in oval shape, he invented the barbecue briquettes. He took him 15 years of experiments to achieve that in a natural way, free of chemicals. In this slide, you can have an optical view of our production process. On your left hand, you can see the limestones coming from quarries, and we put them in the kiln. We bake them by using the exhausted olive cake, and on the top of the slide, you can see our main production products, quicklime and putty lime. But due to the incomplete combustion of the exhausted olive cake, we collect the black powder that you can see on the right part of the slide, and we create our barbecue briquettes with unique advantages when used. Big calorific power, easy to light up, no creation of smoke, sparkles and bad smell, and emits 30% less carbon monoxide during combustion than wood charcoal. Last but not least, the ash which is created by the usage of our briquettes contains nutrients like nitrogen, potassium, sodium, copper, manganese, and boron, which exist on typical fertilizers. So it can be applied to soils or to plant tissues to supply one or more plants nutrients essential to the growth of plants. As a certified company of ISO 9001 and ISO 14001, we carefully monitor the quality of our production process at each stage to ensure compliance with our quality standards. Believe me, it wasn't an easy process to sell our briquettes back in 1992. because people in Greece in that time had connected the word briquettes with chemicals. Many people believe it also today. Although the last 10 years we export our products in many European countries and also in Canada, USA, and Australia, using the appropriate packaging for every country, as you can see in this slide. Not only we sell our product, but it meets high standards to countries like Germany and Sweden. As I already told you, Germany by far is the largest importer of charcoal among the EU countries. So the Germany's first eco-products testing magazine, Ökotest, which helps consumers make the right purchase decisions and set special emphasis on health and environment, with some millions of readers, rewarded our briquettes as one in 3 excellent brands in eco-friendly barbecue briquettes in July 2022, between 18 barbecue products. Also, our partners in Sweden have been certified with brand biofuel as good environmental choice, which is the only label in Sweden run by an environmental organization. For 10 years, we were members of European EMAS. The initial stands for Eco Management and Audit Scheme, which is a premium management instrument developed by the European Commission from companies and other organizations to evaluate, report, and improve their environmental performance. The DG Environment of the European Commission was rewarding the excellent work of EMAS registered organization in environmental protection by introducing the EMAS awards. We have managed as a company to be twice European winners on EMAS Awards 2009 and 2014, and also nominees on EMAS Awards 2010. On 2009, the theme of the award was supply chains including green procurement, and on 2014 was effective eco-innovation supporting improvements in environmental performance. And as nominees on 2009, the theme was resource efficiency. In the wake of the adoption of first Circular Economy Action Plan from European Commission in December of 2015, in January of 2016, Business Planet, a 3-minute TV magazine in Euronews channel focusing on SME success stories, made a video. On this episode, the topic was circular economy and the European Environmental Management Tool, EMAS. Our company was participating as a perfect example. Every day, Euronews is reaching 10 million people around the world. Our latest big achievement was on 2018, when we managed to be national winners and European runner-up in the category The Management Award for Micro and Small Companies at the European Business Awards for the Environment 2019. Those awards are initiative of the European Commission Director General for the Environment and recognize businesses that successfully combine innovation, competitiveness, and outstanding environmental performance. It is worth mentioning that from 161 participated companies from 19 European countries, only 22 companies from 9 European countries managed to be in the finalist list. In the history of the awards since 1987, only 4 Greek companies have managed to be in the European final list till today. One of them is our company. Also, we were awarded as an SME champion in 2019 at the International Conference for Resource Efficiency and Circular Economy in Brussels, organized by European Resource Efficiency Knowledge Center, which is now merged with European Cluster Collaboration Platform. We were awarded from Dr. Ulla Engelmann, which is the head of Unit for Advanced Technologies, Clusters and Social Economy within DG Grow, the Director General being responsible for internal market, industry, entrepreneurship, and SMEs at the European Commission. Now we are one of the fewest good practice examples in Greece of the European Circular Economy Stakeholder Platform. The title of our project is From the Production of Agricultural Lime to Summer Barbecue Olive Pitch Makes a Perfect Circular Fuel. We have been added in one more web platform from Business Europe, which continuously brings new examples of innovative ways in which industry and SMEs added to the circular economy in Europe. Also, we have been added as a successful example of value of circular. Sorry for that. We have been added as a successful example of value of circular business model with title Value Recovery in the European brochure on the topic Circular Cities Solution Booklet in 2021, published by Smart Cities Marketplace, a platform of the General Secretariat of the European Commission for Energy. Also, our projects have been concluded to the European Network of Rural Development, which supports the effective implementation of EU member states' rural development programs by generating and sharing knowledge, as well as through facilitating information exchange and cooperation across rural Europe. And here you can see some posts about us from social media, Facebook, Twitter, and Instagram of the European Commission's Environment Director Generale, which of course supporting our efforts. Our product is being recommended from NABU. The initial stands for Nature and Biodiversity Conservation Union, which is one of the oldest and largest environmental associations in Germany, founded in 1899. NABU's main objectives are the preservation of habitats and biodiversity, the promotion of sustainability in agriculture, forest management, and water supply and distribution, as well as to enhance the significance of nature conservation in our society. On January of 2021, we managed to be members of EU Business at Biodiversity Platform. The platform counts around 450 members, having as a common goal to foster integration of biodiversity consideration into business activities. In brief, our environmental and social impact of our company are limitation of industrial pollution, reduction of fossil fuel extraction, restraint deforestation and forest degradation, increase biodiversity, eliminate waste by reusing it, resource efficiency, energy saving, economic benefits, sustainable development, improving the quality of life. So, we produce an eco-innovative certified product 3 times awarded in 2009, 2014, and 2018 from the DG Environment of the European Commission for Eco-Innovation and Excellence in Environmental Performance. It has been also promoted from the European Commission and other European sites that engage in circular economy and bioeconomy. And according to United Nations reports in 2022, alternative raw materials such as agriculture and other organic waste should therefore be used more widely to produce charcoal. But on the other hand, Europe imports annually at 75% wood charcoal from third countries. Every year, millions of tons of potential illegal wood enter the Europe as charcoal unregulated. There is limited recognition and awareness of byproducts. There is lack of promotion and motivation for such kind of products. For instance, let's say less fat for such kind of products. Also, lack of education for circular economy, bioeconomy, and environmental management system. For customers, the terms of circular economy, bioeconomy, ISO 14001, and DMAS are unknown words. There is no European eco-label for such kind of products. How the customer will recognize the environmental excellence of the products on the shelf of a store, if we assume, of course, that customers know that label. And at the end, or maybe I should put it first, SME struggles to access finance for developing new products and support growth plans. Though, don't forget that an enterprise, in order to survive, must sell the products it produces. Is it easy to do it? Especially for circular bioeconomy products? Food for thought. Thank you, and I'm at your disposal for any questions or clarifications. Thank you very much.
Mr. Naso, wow, what a wonderful presentation. Your work has really inspired us all. Hopefully, we can visit your facilities in the future to see how you make those incredible solid biofuels. Really thank you for being here with us today. It's time to move on to our last presentation for today's webinar. Let's welcome our next speaker, Mr. Alexandros Geka, who will share with us the vision, the efforts that their team has made in order to found Agrigas, an enterprise that processes biomass and produce biofuels and energy. Alexandros Gekas is the Chief Operating Officer at Agrigas Energy, an electrical engineer and computer engineer, graduate at the Polytechnic School of Democritus University, and holds a master's degree in mobile and pervasive computing systems. He has extensive experience in as an inspector and supervising technician, and has extensive experience in the maintenance of the electromechanical installation. He specializes in biomass installation for the production of electricity and heat, and has participated in training seminars on the heat pump and the program of energy inspectors. Mr. Geka, thank you very much for being here today. We are already late, but we can't wait to hear your presentation. Thank you.
Thank you very much, Vasilis. First of all, I would like to thank you for the invitation to participate in this webinar. And for once again, I would like to apologize for any noise that you are hearing through my presentation, because we are near in the field for the last construction steps for putting in operation our plant.
We totally understand, of course.
So I will share the screen. I'll start. Please confirm if everything is okay.
Yeah, we don't see it in full screen, but we can see your screen.
Okay. Well, Agrigas, it's a company founded in 2015 as a result of years of research of its engineers that investigate a method for converting various types of biomass, mostly agricultural residues, are available in our region, into gaseous fuel, which is the most flexible form for fuel. In addition, we were focused on finding ways to reduce the pollutants produced during the combustion of biomass. That was the triggering from our experience as a consulting and installation of biomass appliance, boilers and stoves, about 2 megawatts of thermal power in the year from 2010 to 2012. After research, we would find that gasification technologies achieve both goals from reduce pollutants and make biomass and gaseous fuel. We have visited many gasification plants in several countries around the world, starting from India, US, and Central Europe, Poland, Germany, and UK, in order to gain extensive experience from the installation operation of such types of gasifiers, as well as the connection with electricity and heat generators.
Yeah, Mr. Geka, sorry to interrupt you, but we stuck on the first page of your presentation. I'm sure that you have already.
Yes, I am in the second. You see only Agrigas?
Yeah, that's right. We can see only the Agrigas slide. If you want to share it again, or we can do this for you, whatever you prefer.
Okay. Now.
No, we stuck in the first. We see Agrigas. At least I can see only Agrigas.
Agrigas logo.
Yeah.
Sorry, I will stop share.
Yeah.
And share again.
Okay. Yeah, we see the third right now. Yeah.
Okay.
The brief history. Yeah. Okay.
Okay. In 2012, the company installed a small prototype gasifier with output of 10 kilowatts electricity from Berkeley, USA, where part of an engineer of the company participated in 3 days seminars in order to have a taste what gasification procedure is. During this period, we were tested many biomass fuels as wood residues, almond apricot kernels, also residues from heat cotton and corn cultivations here in the region of Larissa. As a result, we were encouraged to proceed to create a production facility of 0.5 megawatt, which is the final stage and expected to be in operation in May of 2023. The company, following the implementation of its strategic planning, proceed through the study and design of a gasification plan using biomass with the capacity above mentioned and the possibility of connection to a hydroponic greenhouse. You can see a small, we are here in a small presentation of the company with the main target of the unit capacity of 500 kilowatts. consuming about 4,000 tons of biomass and produce about 4 megawatt hours per year. The production capacity will be.
I'm sorry again. You refer that we see something that we don't see. We stuck in the third slide. Just I want to inform you. I'm really feeling very sorry for.
I'm very sorry. I don't know if I have something to do from.
Do you want to stop the share and maybe I can share the screen and you can talk me to next slides? We can see the company presentation now. I don't know why before you stop we saw the presentation. How you want to share the screen or do you want us to do it for you?
I don't know what.
Maybe Vasily, you share the screen.
Yeah.
And then Mr.
Okay. Now you see the screen.
No. Now we just no. Just give me 1 second to. Okay. You share the screen?
Yes.
Yeah, we can see in full screen right now. Okay, maybe now it's fixed.
Okay.
Okay.
Well, as I already told and I repeat for your information, we are consuming about 4,000 tons of biomass and produce approximately 4,000 megawatt hours per year. The construction unit lasted 22 months. It was an extensive period through COVID situation and other events that took place. As the last was the war in Ukraine. A brief process description. Please, Vasily, please confirm that you see the flow chart of production process.
Yeah, we can see.
Yeah,
it.
okay. Thermal gasification is the chemical conversion, high temperature of materials containing carbon atoms into synthetic gas. This gas can be used to make chemical, and because it is fuel, it can also, after proper processing and enrichment, to replace natural gas for electricity generation. Gasification technology is based on chemical reactions that break down the structure of green waste into simple molecules, as opposed to synchronization, a process that creates more complex chemical compounds. The technology uses 3 processing steps to generate electricity from biomass. Each of these stages have been used for decades in similar application abroad to generate both thermal and electrical energy. Here you can see a description of process flow chart of agri-gas. The base products of the plant are electricity, thermal power, pellet, and biochar. The main project in the production is electricity with gasification. The produced syngas, after being produced in the gasifier, goes through purification, filtration process, and is led to a generator or electricity generation. The electricity produced is channeled in the distribution network in feed-in tariff with 190.30 euros per megawatt hour. After a step-up transformation, go to the public electricity. The whole process does not produce waste except for the gaseous emissions on the generator that are within the limits of national and European law. The thermal power that is producing through this procedure for the first stage is not using anywhere, but only for drying the biomass if it is needed in the dryer of the pellet line. Biochar is a byproduct of the whole procedure. It's what we can have after the gasification of the biomass. In order to reduce the time, I'm not give any further description. If anyone would like to learn something more, I'm at your disposal after the end of the presentation to answer questions. and go to the pellet that is the produce of our company before the gasification. The pellet is the final form of the biomass that can be used in the gasifier in order to achieve the production of syngas and respectively the electricity production. The company produces pellets from wheat straw, barley, oats, corn, and mixture in different proportions. Straw is the main product with high calorific value and low moisture content. It has been used for animal feed, animal bedding, and is the most common here in our region that we can find from late of May till the early of July. Plant location is in central Greece, position that is according to the Greek law for supporting such facilities from biomass and collecting and producing electricity. You can see our storage in biomass and equipment. The company Agrigas has all the appropriate equipment in its own for the collecting regarding including balers, tractors, and all the auxiliary equipment for cleaning all the fields and collect the biomass. The competitive advantage of the technology is to use a very low energy footprint. Using a unique reactor and filtration technology, there is almost no waste and very little water use. In addition, the whole process is fully automating, reducing staff requirements and the immediate consequence of reducing overall labor costs. Possibility of utilizing a wide range of projects as raw materials, agricultural residues, wood biomass, biological treatment waste, plastic, household waste, etc., without requiring changing to the gasifier. It's an opportunity, but for the beginning, we're still focusing on agricultural residues. In this picture, you can see the circular economy that is implementing in Agrigas. We have collecting the material, and we are coming back after the harvesting of biomass residues to through biochar, through the fertilizing and for the crops and for the hydroponic greenhouse. Some pictures of the installation, pre-construction and through construction. We are stepping up this time, and we are ready in about 20 days to start operation. You see the facilities from upper side. It's in the final stage. In these pictures, you can see the gasification tower and the auxiliary step equipment. Thank you for your attention. I'm at your disposal for any questions.
Thank you very much, Mr. Gekas, for sharing with us your expertise in this way. Your facilities are very inspiring, and we hope we can visit in the future. And thank you very much for being here.
You're welcome. You're welcome.
Thank you very much. So we are late about 20 minutes, but that was the last presentation of our webinar. Let's make a quick wrap up. The webinar was about the salt biofuel production and circular economy. We have heard about the various types of salt biofuel and the main properties. We learned about the significance of certified schemes and how it is important in order to expand the production of biofuel. We delve deeper into the exploitation of biomass waste streams and hear about how successful examples that already exist in Greece, twin companies, Klimis and Agrigas, that process and standardize the residual biomass and produce products. Probably we have time for one or two questions. We'll now open the floor for questions and comments. please feel free to ask questions. You can either write at the chat box or open your microphone and address the question to the corresponding presenter. So do we have any questions from the audience?
Yes, hello, can you hear me?
Yeah, of course.
Hi, my name is Dimitris Papangelis, and I have a question for the representative of a Klimis company.
Yeah.
And since I'm interested in the solid biofuels in Greece, I'm wondering, were there any sort of what were the difficulties that the Klimis company faced in the promotion of the use of biofuels in Greece, and what kind of steps did the company take to address those challenges posed?
In order to, thank you for the question. In order to create the product back in 1977, it was difficult because there was no machines, no internet action, nothing. It was very difficult. That's why the inventor, grandfather Klimis, took him about 15 years of experiments to do that. And don't forget that we are an SME. There are not research and development sectors to do experiments, and we have to do. Our main job was to make line products, because if we didn't make that for living and waiting 15 years to sell our products, it won't be viable. So all the awards that we have from the European Commission made that product known in Europe, because in Greece, many reports are only in Europe, not in Greece. If you do a Google search, you will find many articles from European sites, not from any Greece. There's no site that promoting like a European stakeholder platform that promoting secular business model, because we don't only have how to management our waste or just do recycling, because there is a confusion about circular economy and recycling in Greece. Recycling is a strategy of circular economy. Economy is on the top priority. There are many strategies, and we were pushing that product. It's not easy because the market is full of wood circles. And as you saw in my presentation, there are no, Europe is not showing the way. We cannot have, for instance, eco-label. It's something that we should put in our product. We cannot put it, even if we had also IMAS, which is an environmental management system. You cannot put the logo in your IMAS, and of course nobody knows what is IMAS and what is ISO 14001. So the other thing that we have to think in order is to sell our product is to change the consumer behavior. And in order to change the consumer behavior, we have to educate them first. If we don't do that, it's a dead end. Because as I told you, as a company, you have to sell your product. And if for a startup, it's not easy to get money easily, and it takes time, a lot of time and a lot of efforts. Imagine us, we took us about 30 years to be now in the position that we are now, and we're still trying. So it's not easy. Now we are making logs with olive pitch also, but it's not easy. You don't get easy finance. SMEs cannot get easy finance, even if you hear that. No, it's not easy. So it has to be changed, all the system, if we want to be to go to climate neutrality.
Yeah.
The first thing is to change customer behavior, I think. Thank you.
Thank you.
Thank you for your answer. Yeah.
Yeah,
You're welcome.
Yeah, thank you very, very much for your answer. Do we have another question? We probably have time for one more, maybe. Does anyone have another question? Okay. In the chat, I see one. Yes. Yes, Dionysi? Okay, you asking Mr. Adamatis, how does Elavion envision the future of the salt biofuel industry, both in Greece and in Europe? Great question, Mr. Adamatis. Floor is yours.
Yes, thank you for the question. It's really a big question mark, I would say, because there are different policies about renewable energy, and actually, renewable heat is one of the main weapons of bioenergy across Europe, and unless it is being, standardized, and unless there are successful examples of using certified biofuels like pellets, certified pellets in appropriate appliances, then the general perspective and about biofuels will not improve much. And also, as far as the difference between the biofuels and natural gas, we see that especially in Greece there is a strategy of expanding the natural gas networks in order later on in future decades to green it with renewable gases, either biomethane or at earlier stage green hydrogen. But in the in-between, there is enough space and enough room, especially in the agricultural areas where this network will never come, or it will be very expensive to expand, to use certified solid biofuels out of residues, and also to, in this example, by using this to give a good example of circular economy, and to also to have the opportunity to get for the farmers to have another income, because at the moment it's the practices that are being done, as I presented in my presentation, is not that they don't want to have environmental solutions with biomass residues, but there are no incentives for them, a price for their byproducts. Or on the other hand, there is no punishment in place as a gate fee, as it happens with solid municipal waste. So to sum up, I think that there can be a future, but it has to be organized in a better way. It has to go through certified schemes, through the use of appropriate technology, which is always expanding, and especially European technology, because biofuels are depending a lot on European technology.
Thank you. Thank you, Mr. Nico, for the answer. We don't have enough time for another question, so it's time to end this webinar. You can check the BECoop website that contains a lot of information about the activities that may take place in the framework of the project. Thus, I urge you to join us either on social media, visit our website, register in our newsletter, join our knowledge exchange platform, and use the tools in order to investigate the degree of maturity of your initiative regarding the biomass exploitation. I would like to congratulate the presenters for the great presentations. You can find all the webinars at the website. All webinars have been recorded and located at the knowledge repository of the BECoop website. So once again, thank you for being here today. I hope you all really enjoy the webinar. Have a lovely afternoon. Goodbye, everyone. Thank you very much for being here.
Thank you. Goodbye.
Thank you.